In this video, I wanted to talk about systems that have multiple solutions or no solutions, and also how we write those answers. And the summary of how we write our answers is very similar to back in chapter 1 when we talked about the different types of solutions to equations and how we express that. But let's just jump right in. I already kind of talked about the graphical situations where the only time that two lines could not overlap and have an answer is when they're directly parallel. If they're parallel and do not have the same intercept, then they're never going to cross. They're not going to have any potential solutions. If they are parallel and they directly overlap, that they're right on top of each other the whole time, that means all the points on the line are common. And that's a case when we say they have infinite solutions, which is not, I talked a little bit about this before, but infinite solutions is not a very good answer because it's not very specific. But let's go ahead and look into this. So it's to solve the following systems, write your answer as a set. So we'll practice using set notation and kind of how we recognize it. But in the case of this system, well, we could either use substitution or elimination. Let's just go ahead and do elimination. So to match up -2 and 4, I would want to multiply the first equation by 2. And I need to zoom in on my tablet. There we go. And if I multiply the first equation by 2, I'd have -4x plus 6y is equal to 12. And I could leave the second equation alone because x is a proper match. So that, and now if I add those two equations together, I would have 0 plus 0. Notice that actually both eliminate. And this is one of the ways that you can recognize when a system will have a weird answer, is if both x and y eliminate, then you're not going to come up with a singular answer. You're going to run into something weird. In this case, that all leaves me with 0. And I'm going to go ahead and write 0 because that's all that's left when everything is gone. And then 12 plus 11 is 23. And in this situation, you might remember this from chapter 1, but anytime in math when I wind up with an equation which is false, it's not, obviously it's crap, what that means is that everything else was crap and that really whatever I was doing is, so there's something wrong with it, meaning really there is no possible solution. There is no way that there is this commonality. And again, basically this is indicating that those lines are parallel. If you go back and analyze the slopes of these lines by solving for y, you'll see that they are both positive 2/3 slope. But the problem with those is they have different intercepts. So they're never going to cross. And, even if we try to find an answer, we're going to wind up with garbage. And so basically, in this case, we get a system which is referred to as inconsistent. But basically, it just has no solution. So how we could just write our answer using the null set symbol, meaning, okay, there is no answer. We're just going to give up. Or you could write no solution, no answer, whatever. But, just stopping here is not enough because we're not really, this is not a conclusion. But in math, if you do run into such things, that's pretty much going to be the conclusion. Again, it's depending on what you're doing, but. Now the second one is very similar, but let's look at the difference. So to prep this one for elimination, we could multiply the first by 2 in the same way. That would leave us with 6x minus 4y is equal to -2. And in the second equation, we can leave it alone. And notice if now it's ready for elimination, we go ahead and add those together. 6x minus 6x, 0, -4y plus 4y, 0, -2 plus 2, also 0. So what we'll be left with is 0 is equal to 0. And again, like chapter 1, this is always indicative of a situation where there's infinite solutions, where because this is an identity, this is basically always true. What it's implying is that these equations originally were also always true. Now, I've seen a lot of students write for their solution to this just infinite solutions, that's it, and that's how they stop. Which is not wrong, but it's not very specific to what our answer is. And so there's kind of a better way of answering this. Instead of just writing infinite solutions, we could actually specify, well, what are the solutions? And basically what we have here is those two lines are the same exact line. They're overlapping And if you solve them, you'll see that both of those lines have a slope of, let's see, it would add 2 and add 1. It would be 3/2 x plus 1/2. So both lines are going to have a slope of 3/2 and an intercept of 1/2, meaning they're just the same line. And every point along those equations is a solution. So how we can write it more specifically in set notation is I could write it's a set of points x comma y such that they satisfy one of the original equations. And it doesn't actually matter which equation you write, because they're both, you could even write it in slope-intercept form if you want. But basically, because those equations are the same line, our answers are also the line. And so we could graph it, and all the points on that line would be the set of the answers. But this would be how I could actually write it as a set. And if you're wondering, do I need to remember all of these little details? Not necessarily. Again, all the little things aren't important. What is the most important thing is the strategy for solving the system and being able to read in between the lines when we have, no pun intended, when we have an answer like 0 equals 0 or 0 equals 23, we can determine, what does that actually mean? And we often refer to systems which are the same as dependent, because y and x are dependent on one another, just as they usually are within an equation, and we don't have just a singular solution.